Let's talk about the properties of alkanes and some of their applications in this little video. So the physical properties of alkanes, and in physical properties we talk about boiling points, melting points, density, solubility in water, and some odor stuff, okay, if it's important. But in any case, so the first thing here, boiling point and melting point. So here what we're talking about is, of course, the size of the alkane. Alkane is CnH2n plus 2. So they really don't have any polarity going on with them. So essentially it's all dispersion forces that we are dealing with. So the intermolecular forces are really low. So which means that the boiling points are going to be very low as well. So which means that you actually start with gases. So you can see here that the melting point, boiling points are really low at minus 200 or minus 100. And so then it keeps increasing as the number of carbons increase in there, which is valid because the electron density is increasing, so dispersion forces increase, and so the boiling point also increases with that. So in general, what happens then is carbons 1, 2, 3, so methane through propane, they would be gases. Then butane is kind of like a little bit gas, a little bit liquid, and then you have a whole bunch of liquids going on until C22 or C24, and then you start getting solids. Okay, so you have all these three phases going on in alkanes. So the smallest alkanes are going to have very low boiling point, melting point. Now you will remember, of course, that if you have straight chain compounds, they are going to have higher boiling point, melting point than branched because of the less intermolecular forces between branched. Okay, cycloalkanes will have the same kind of properties as alkanes. So no new information there to remember for you. Here, it's just a slide to show you that the physical properties of constitutional isomers. So you can see how the boiling points and melting points are for straight chain compounds versus branched compounds. Okay, so take some time just to look at the physical properties of these so you understand how the physical properties are changing. Then let's talk about the solubility in water. So of course, solubility in water is going to be no, zero, none. Because, well, you can't say none, this might probably very small amount, but in any case, it's really, essentially no, because alkanes have dispersion forces and water has hydrogen bonding. Both of them are worlds apart, so they are not soluble in each other. So because they're not soluble in each other, we have to talk about density. And density we generally compare to water because water is our main solvent for most reactions and common things that we do in our lab. And so water also has a density of 1. So it's kind of easy to talk about density and compare it to water. So in any case, density of alkanes is less than water, which if you think about where we find alkanes, like petrol and all that, so when there is a spill or something like that in water, the oil floats on water. Okay, so that's the density is lower than water, so it floats. Odor generally is not that bad for alkanes. It's not it's not bad like stinking. Okay, so it's kind of pleasant smelling. It's good. You may not like it, but it's not a pungent or a bad smelling compound. Any of those alkanes. So what are the sources for alkanes? Most of the alkanes are obtained from earth through drilling, so which means under the earth, and they actually generally come from the decomposition of living things, whether it's plants or animals. Yeah, we all decompose to give oil at one point or another. So they all come from under the earth. So whether it's under the earth, on earth as such, or under the water as in under the ocean. So wherever it is, it's still under the earth. Okay, and so natural gas methane is also obtained under the earth. So almost pretty much all natural gases or petroleum products, they're all obtained from under the earth. Okay, natural gas is generally obtained by a process called fracking, and you might have heard about fracking, where they pump water through the earth in order to break it apart in order to release the gases. So that's kind of fracking. You can read more about it. Petrol is also obtained from under the earth. In general, a lot of these extractions are polluting and they are dangerous to us. It's also not a renewable fuel, which means that once you take it out, it's done. So sometimes it might get over, okay, at some point. So which means you're doing all this pollution and everything for a short period of time. It may be for our lifetime, but still it is short according to Earth's time. The alkane extraction process is pretty intense. A lot of countries have these processes, and the interesting thing is that once you do get material out of the earth, like petroleum products, it's not just the alkanes that you get, it's a lot of other things also that are obtained, which are used as starting materials for a lot of other things like plastics or drugs, and drugs like in medicines and things like that. So it's not just petrol as in the gas that we use in our cars that is obtained from earth. There are a lot of other things also. Um, there's a whole lot of debate about this. We can't really do that in a PowerPoint, so that is something that could be done in a live lecture sometime. In any case, moving on. So cracking is a very specific chemical process that is used to make some unusable alkanes into usable products, because not all alkanes, for example, ethane, is not really used for anything per se. Methane is a natural gas that we use for heating in our homes, and propane is, of course, the gas, and so on and so forth. But some alkanes are not very useful by themselves. So then you can use cracking in order to make larger alkanes, or to crack them to smaller alkanes to make them useful. So there's a whole lot of chemistry going on here with extraction and then processing. So applications here, just a little bit about that. Of course, fuel source is the biggest thing about alkanes, is that they're very good for energy. So of course, we know of natural gas, methane, which is used to heat your homes. Also, if you have gas stoves in your homes, then it's used for that. So then there's the compressed gas propane, which you can use for camping and such. So you will see that all the time, the tanks that have propane written on them. Lighter fluid is butane, and it's not just that you find in lighter fluids, you can find in multiple things where you need to light stuff. Petrol, of course, is isooctane, which we put in our cars, which of course, if we don't have, we don't know what we'll do. Kerosene is a very common fuel that's used in homes for cooking and such. So all these products, they're all coming from different number of carbons, and they're really the basic. So basic function is production of energy, because when you combust them, you burn them in oxygen, you get a lot of energy. Okay, so that's really their main function. A lot of alkanes are also used as solvents. So for example, even in our labs, in our teaching labs, we will use alkanes as solvents. Even industries will use alkanes as solvents because they're non-polar, and so they're very good for dissolving organic substances. So it's very common solvent. And then there could be other things like wax, like in candles and Vaseline. These are all alkanes, and these are solid products. But as you know, you burn wax also, okay? Candles will burn nicely, and so that's because they're organic substances and alkanes. So in general, from this presentation, hopefully you are able to predict physical properties of substances. If you don't remember all the applications, don't worry about it, although it will be nice if you can. But really the physical properties is the main thing over here. You should be able to compare physical properties across different functional groups also, okay, to say which one has higher boiling points or melting points, etc.